Yo, how we doing, everybody? What's going on? Okay, so my headphones are being a little weird. Does the audio sound right? I mean, as long as you guys can hear me. All right, yeah, so what are we doing today? Today we are doing malware analysis. It's a pretty cool kind of topic. I'm pretty sure you guys already know what malware analysis already is, right? We're looking at malware sample and we're analyzing it. That's pretty that's pretty much it. How's everyone doing? Here, I'll go on my screen. Andreas says, yo, what's up? All right. I already have Flare booted up and Remnux booted up. If you guys need a good type of setup, I'll recommend. Just click on the YouTube button. Yeah, if you guys need a good setup, I have a video right here that shows how to do the exact lab setup that I have. So if you guys wanted to like follow along or anything like that, that is totally a viable option. All right, yeah, but enough talking. Jack family, hi, what's up? Hold on, my headphones are being like super weird, guys. I'm going to see if I can fix these real quick. Jack family, what's going on? Yeah, this is the sample we're going to use. It is the, I don't know, it's from PMAT Labs. If you guys haven't seen or heard of the PMAT, TCM PMAT, it's probably one of the best resources to learn malware analysis that I've seen, at least. Where's the site? This is the GitHub, but where's the site? What? TCM security. Man, what? There you go. All right, yeah, so where's the PMAT? Right here. Yeah, so it's a great course. It teaches you literally like how to do malware analysis like it's nobody's business. It's great. It's honestly great. One of the best courses I've taken. Definitely up there with like Maldev Academy, maybe some other ones. Okay, I'm going to pause the music for 1 second so I can freaking fix the audio. I'm so sorry, guys. I know I was going to have these technical difficulties like as soon as I started the stream. I probably should have made sure everything was working before we started, but you can't always, you know, have everything. But while we wait for that to work, let's go ahead and actually pull the sample out. It should be in samples, sound. There you go. Okay. Is that good? All right, perfect. I'm so sorry, guys. Let's turn the music back on. Whew, man. All right, let's actually focus. So let's go on labs. We want to go to, honestly, I probably could just get it from the GitHub, the 7-zip. Yeah, let's just do that. That's better. So we'll go to our terminal, cd to downloads. Let's open this up in Nemo. I'll throw this over and we can just drag and drop it. Cool. Close this. We can close this. All right, and can you open? Default password is infected. and then we can pull the malware sample out. So I think the GitHub has like a little prompt it wants you to read. So we'll check that out real quick. Do I want to do a write-up for this? Yeah, let's do a write-up for this. Okay. We'll call this PMAT process injector. Cool. And then malware analysis notes. Cool. So overview. There you go. We'll drop that overview. All right. What's the day today? It's 20/24/07. And the 6th, I think. Yeah, perfect. So, you know, it's like literally right up there. I just still, I don't know, fail at this sometimes. All right, cool. So we got title. What's the title? I know it's a process injector. That's about all I know. I haven't touched any of these samples in like, I don't know, eons. It's been a hot minute. So I think all of us are going to be in for a surprise. So resources, we'll want to link the actual repository. So I'll go ahead and like this, and let's go ahead and hit a virus total scan in a second and just get on with business. So I'll just say sample, if I could type, I still can't type. There you go. And then virus total. Cool. So we'll go into this. Okay, CD into desktop, and we can SHA-256 sum the malware. Okay, so we'll copy that, and let's go on virus total. What's the other like new virus total? There's a really like, so I think it's Malware. Let me see. I know you guys can't see my screen. I'm checking something. Okay. Hey Cosmo, what's going on? Yeah, it's Malware, right? Malware. No, it's not Malware. It starts with Mal. Man, they're all the same to me, man. Analysis. Malcore. That's what it is. I wanted to try it out. It looks pretty cool. Is PJMR practical junior malware researcher, right? I forgot. PJMR. Is this TCM's one? It's like the fancy TSM or TCM one. Yeah. I mean, they did a really good job with the course. I haven't taken the certification though, but the original course, like the PMAT, the PMAT, is really good. Yeah. I mean, if you're good at your job. But yeah, looking at this, it says Metasploit, generative payload, Trojan. Yeah, so it's pretty heavily like hit by antivirus. So it's pretty interesting. All right, let's get to the actual stuff. So we're going to do a floss and hit that malware. Save the floss.log. The malware dev series was super informative. Hey, I appreciate that. I'm not done with it yet. There's still videos I want to add. I just haven't made the time. I want to do I want to cover some C2 stuff. That's a definite. Yeah, I wanted to do C2. I wanted to do some obfuscation techniques as well. And then maybe like, I don't know, some more like lower level assembly stuff. But yeah, I'm not done with it yet, but I'm glad it's been helpful. Whoa. All right. So we finished that. Let's go ahead and run this through Kappa, right? Kappa. And let's get the malware. While we're waiting for this, let's actually throw this into PE Studio as well. And we'll just drag and drop you in here. Cool. Did I hit enter on this? Try from Malware Bazaar. I haven't used Bazaar in a while. Bazaar. Was it abuse, right? Select all the squares with buses. Who driving this bus? Y'all remember that Vine or me or whatever? What's the syntax? Oh, SHA-256. SHA-256 colon. Nothing, really. Okay. Okay, let's keep going and see some of the stuff we got here. So yeah, Windows, PE, cool. Obviously. Execution, share modules, file, execution, blah, blah, blah. Allocates memory, terminates process, reads files, writes files. That could be interesting. Capability. So it's compiled with NIM. That's pretty interesting. Read file, get thread, execution. Okay, allocate RWX memory. Okay, so it looks like, yeah, this is definitely a process injector. It's allocating memory, it's loading memory, it's pushing something into some other process's memory. So we'll have to see how it's working through that. But that's about all the other information I really care about. I think in our notes, we'll go ahead and, whoops, that's not what I meant to put. So, SHA-256 sum. Is it 32 or 64-bit? Did it say? Let me see what PE Studio said. Flashbang. My gosh, I'm so sorry. Use detect EV. I have it right here, bro. I'm still learning all these tools. Not still learning, but like I haven't really used detect easy. Yeah, 32-bit. Okay. So let's fill out some of this report because I figured, hey, we might as well make a report. 32-bit. Language is NIM. Category is a process injector. File path. There's no file path. Internet connection, debugger detection, or virtual machine detection. We will see. All right. So let's look at some of the imports that it has in here. So virtual protect. Get current process ID. Yeah, so a lot of virtual lock, virtual protect stuff. Is there any other interesting functions in here? Load library. NIM sucks? What? What? Hold up. Hold up. NIM sucks? Time out, man. Why? What sucks? What sucks about NIM? I'm very curious. Low library. That's interesting. Are they using oh yeah, get proc address. Okay, so it looks like they're here. We'll take a screenshot of this because this is actually kind of important. Yeah. So, whoops. We're going to get this right here, and then we'll put a square around. So load library sketch, get proc address a sketch, and then even like virtual protect. All right, so we're going to have to check all those out. What basic static analysis? Yeah, that's the IAT right there. Were there any strings that we didn't look at the strings yet? Yeah, was there anything else I wanted to get? Flash strings, P Studio strings. I'm not getting the P Studio strings. No, we'll just stick with the Flash strings. All right, let's check those out. Was there anything else in Kappa that I wanted to talk about? Contains embedded PE file, so it's packed. Okay, so I'll probably take a screenshot of this too. And then where's, so allocate RWX embedded PE file. I think that's all we really care about. So that's pretty interesting. Okay, let's do bold text and then we'll just do Kappa. Okay, that's pretty cool. And I actually haven't really used Kappa before. I was like, you know what, maybe I should run Kappa. Oh, you're just kidding? Okay, I was about to say, I was like, Nim is such a good language. It's like so weird because it's like super Pythonic with its syntax, but it's also just like, I don't know. It's just weird, man. All right, so let's go ahead and take a snapshot. Actually, wait, not just yet. We'll finish looking at those strings first. I'm gonna see if there's anything in there. We'll go vim floss.log. So let's look. Yeah, you're gonna already see nim right here as like a really big, that's super weird, dude. All right, so nim, is there any PowerShell? Is there any domains maybe? HTTP. Yeah, it's just nim stuff, it looks like. Here, let's do Codium. Let's see if there's anything in here. He said nim land with the hard eyes. Imagine using C++ when nim exists. I don't know, man. Okay, I'm just use C over C++ because like the only purpose C++ serves to me is classes. So that's the first thing. Yeah, I would probably still use C over most languages. Oh, there's pass in here. Interesting. I don't know if there's any like strings that are like worth noting here. Slash C colon backslash. Oh, did I search that right? C colon backslash. There you go. Oh, look at this. This program can, okay, so this is the embedded executable down here. CRT injector console. You see WW. This is weird, man. All right, so what we'll do is let's proc.nim invalid handle command $1. So it's taking in an argument. This is cool. All right, so we're going to we're gonna basically just copy that. Did I copy that right? Where'd that go? Oh, I see what happened. Slash C, bro, C colon slash. There you go. Okay. 0v. Yeah, we'll go from there. Plus y. There you go. Okay. I was still searching it. So the floss strings, I want to throw this in here. I don't know what language to put in there. Have I never tried Nimlane? It's actually really good. Yeah, dude, like when it first came out, I was able to make like basically obfuscated process injectors and like some shell script like loader type things, and then yeah, they just bypassed AV. Like when it first came out, and then I remember like after a while, I think Windows Defender just started blocking like most NIM applications, and like NIM, like even the NIM compiler, like if you installed it, it would just like flag it as malware. And I think they fixed that now, but I remember like NIM had like a really big advantage. It's weird because like new languages that are like compiled a little bit more differently, things like that, kind of have a advantage in the malware scene. So it's kind of good to use new languages, from my perspective at least. All right. Yeah, I had to press service pack. Nice, man. Okay, let's do some dynamic analysis now. So it looks like it's grabbing some sort of argument and loading it in. I see like some other things were faults. What is that? Were fault.exe. You want it? Sure, why not? I'm on, you know, my Discord's in the description, so you guys can always find me there. So what is Warfault? It's just a Windows problem reporting. Got you. Okay. And then what's what was the other thing that we saw in here? Warfault. I swear there was something else that caught my eye. Public Warfault. Yeah, cert injector console.pdb. Huh. All right, I think this is enough for us to kind of go with the rest of this thing. I don't know if there's anything else that we're going to find that's like really interesting. Yeah, this is all just compiler BS from what it looks like. Yeah, okay. So we'll close this. We'll close this. And we don't need this anymore. So we can close this for now. Okay, so let's go ahead. Let's make a screen snapshot. We'll just say before det. This is for our process injector. Finish. Have you ever tried the Flare on challenge? I have not. I want to though. When do they drop that? Flare, oh, Flare on Mandiant. In 83 days. Sweet. I'm gonna bookmark this. I'm gonna check this out later because I know about it, but I never actually like did anything with it or pursued it or anything like that. Okay, so let's go ahead and finish. Not finish. Let's go ahead and do some analysis. So it looks like we have our snapshot, so we can go ahead and do some dynamic analysis. Let's open up Procmon. Yes. And I'll also open up Process Hacker. I'll just have this be open over here. So let's set a filter, and we're going to do process name is, what is the process name? F2, Control A, copy. Process name is this, so we'll add this, apply. And that's all I really care about for now. We can add more filters later. So let's just run this thing. Oh wait, it's not it's not exe right now. Whoops. Silly me. Exe, yes. Which means in Procmon we need to modify that. Okay. Let's minimize that for now. Yeah. Yes. Okay, so let's double check this. It should be .exe. Yeah, okay. What? Oh, add, apply. There you go. And we'll go ahead, just clear everything. Cool. Let's run the malware. Okay, it ran. Maybe I should be running iNet sim and stuff, though I don't think it needs an internet connection. We should be fine. Okay, so let's go ahead and check out any operations related to anything. So I know it's a process injector. So let's see if we can look at. So yeah, here's the stage 0.exe. It ran war fault. And then it ran war fault with 5076. Interesting. 5076. Okay, so that's the PID for war fault. So that's probably that argument we saw right in here when it's looking for argument 1 and the file handle. That's interesting. Check TCP. I will in a second. Yeah. But it looks like it's doing process injection onto warfault.exe. Interesting. If I show process hacker, can we see warfault anywhere? Or is it not running anymore? Huh. I want to run that through a debugger. Yeah, but let's also check TCP. TCP view. Yes. Local port 445. Interesting. All right, so let's run the malware. Okay, let's warfault.exe. Oh, you saw that? It disappeared before I could actually look at it. I'll run it again. Warfault 8443 at localhost. What? Hello, Commander. Why is this being so slow? Can you do process injection from the host environment? Like on my host machine? What do you mean? Netcat. Attack LMVP 8443. Set up NetCat. Bro, I know how to do this, bro. I appreciate the insight though. Okay, it looks like it's a reverse shell. Yeah. Who am I? Desktop Flare VM. Okay. So that's what it is. It's a process injector that throws in a reverse shell. Let's see if I can we'll do a square. Okay, so that's super weird. I want to look at the Linux machine to the VM. Like inject the process from my host computer into the No, the process injector is running on the Windows box I have here. What I'm going to do is, so basic dynamic analysis. I'll just run this here. I guess this is in the network analysis side. Yeah, so that's super weird, dude. Yeah, I'll take another screenshot here so we can just have it for the write-up. Cool. And then in here, we'll go ahead and throw that right there. Let me center images so it looks a little bit better. Center images. There you go. Okay. So this is with TCP view, and then this is with Netcat listener. Dr. Wolf, what's going on? So I kind of want to throw this into like a debugger, because like if you guys saw this malware, it's using get proc address and load library to actually load the functions in, which is why you only see like virtual lock and those other functions. So it's probably using more functions that it's just loading dynamically at runtime, which is kind of cool. Let's look at that path that was in strains earlier. I'm gonna close this. I don't need this terminal. Yeah, public users public were fault. So if we go to Flare VM, right, temp. What? Okay, this is weird. This PC, local users public. Yeah, and then there's werfault.exe. So let's look at werfault. I would like to grab the shell code for this, or however they're packing it. I'm also curious. Let's check out the copy value. Virus total. So werfault.exe. Here's another one. Any yummy ransomware? No, we got ourselves a process injector today. Process injector. Interesting. Yeah, I'll grab up to there. So that's the werfault, which means, so this was malware.exe, And then that means we have literally a second sample, because this is worth flt.exe. This is a very different sample. So like, is it running? Yeah, so it says Visual C++, 32-bit, imports, current process ID, write process memory. Okay, so this is like the malware. So the first one was like a stage. And then that stager, can we get the shellcode for that? I think that would be cool. Okay, I'll minimize this. I'll close this. Let's open up x32dbg. And we'll open it onto the desktop, malware stage 0. Then we'll set some breakpoints. We'll do what breakpoint should we set? I'll do virtual protect, and then I want to do load breakpoint load. Did that not work? Breakpoint invalid address virtual protect. What was the one that it used? Did I just misspell it? Breakpoint virtual protect. There you go. Breakpoint load library. And then what was the library? Is it load library A? Yeah, load library A. And then breakpoint get proc. Is it get proc address? Yeah, get proc address. Okay. Let's run this thing. Remember the debug commands. Into 7 and then over is 8. So F8, F9. We hit the entry point. We'll run until we hit load library A. They're loading kernel 32. Oh, you guys can't really see that, can you? Let me move this over here. There you go. So you see that they're loading kernel 32, and then get proc. I see an MZE. Okay. Follow in disassembler. Follow in dump. This is mostly null bytes, bro. What? This isn't the same exe, is it? These all look like headers, and then you know what? We'll dump the bin anyway, but I doubt it's anything interesting. Save to file. Desktop. Dump 1.bin. So let's see if this actually got anything, first of all. Yeah, okay, that's why. Okay, so I only pulled out the first fucking byte. How am I supposed to do this again? Wow. Okay. Let's try that. Desktop. Dump one. Save. Yes. Alright, so let's see if this can now get the right freaking dump. Okay, interesting. Can we open up another? Let's open up Detected Easy. So you were asking about Detective Easy earlier. So here's Detective Easy. Desktop, dump point bin, 32-bit, linker, Microsoft linker, DLO 32 signed. Interesting. Strings, why not? Okay, so is this the workfault.exe? I don't think so. I don't know. Let's keep looking at stuff. We'll keep stepping through the code. Oh yeah, I see. There you go. Yeah, I think I pulled the wrong thing out. Yeah. I should look at the arguments. Yeah, read console W. So this MZ is just, it's probably just kernel 32 or something. I'm probably tripping. But read console W, get last error, format message W, local free, kernel 32, create pipe, format message, local free, get last error, say handler, create name pipe, create file, get process, duplicate handle, close handle, create process W. Ooh, maybe I will breakpoint on that. Breakpoint, create process W. Suspend thread, sleep, wait for single object. Yeah, wait for a single object is what executes the thread. Well, I mean, after you execute the thread, that's how you wait for the return. You said Ghidra? We'll check it out in a second. WS232. Is that Windows sockets, right? I'm pretty sure that's Windows sockets. WS232. Yeah, sockets. Yeah. That's cool. So yeah, this is Windows socket stuff. So this is probably what's helping with the that shell that we got later on. Let's keep looking. inet ntop. Then I got workfault.exe. So create process, and this is where it creates the workfault.exe process. That's pretty cool. So if it's creating the process, it's probably going to okay, it's running. Is it sleeping or something? Why is it? See public users workfault 7328. Workfault 7328. Huh. All right, we'll put this right here. All right, so yeah, this call. Oh, I see. So this call is about to call the shellcode. Okay, so this is about to call the process injector, and 7328 is the PID for the normal workfault exe. So this execution right here is going to actually load the shellcode into the exe. I want to see if I can get the shellcode. Here, step over. Yeah, step over this jump. Yeah, execute to return. Okay, which means if I'm I'm gonna step like at a breakpoint right there. Oh wow, so the war fault terminated its execution after a certain period of time. Interesting. Okay, let's run it back then. All right, so I'll remove or just disable. So disable load library. How do you disable it? Disable load library. We'll keep virtual protect. We'll disable get proc address. All right, so run this. Hit the entry point. We get to create process. Okay, so what the hell? RWX? Can you... Oh, is this the shellcode? That's the that's an RWX commit, right? I think you should have a look into dump file Ghidra. I don't think that dump file is important. I think this is what's important. Save. Because this looks like the shellcode. Desktop. Because the other thing was just for kernel loading. Shell code. I think it was just one of the DLLs in memory. Shellcode.bin. I'm pretty sure this is the shellcode. Here. We'll do... Okay, so scdbg shellcode debugger. We'll do our shell. Oh wait, this is my freaking that's my rev shell. Whoops. Alright, shellcode debugger / and then we'll do our shell. Oh my gosh, cd into desktop. Freaking hate this stuff. Alright, shellcode debugger. That's probably too small for you guys to see. I'll zoom in a little bit. Can I zoom in? How do you zoom in? I honestly don't know how to make this bigger. Control scroll wheel, Control shift plus, Control plus. What? Settings, fonts, size, maybe like 20. All right, yeah, that should be better for you guys. Okay, let's try this for real this time. Shellcode debugger, and then the file we want to use is the shellcode.binary. S and 1. Yeah. That's the shellcode, dude. See that? Load library. Start the socket. Connect at 127. Wow. Keep doing this by accident. Here, let's take a screenshot. That's pretty neat. All right, so was this advanced dynamic? Can you explain that command to me? Yeah. So scdbg is the shellcode debugger. It comes with Flare. And basically we're taking the file out, and this flag basically says take as many steps as you want. Right, so it stepped through it as many times. We don't need to like set a specific number of steps. So steps -1 is steps like infinite. So if we wanted to step only like, you see how many steps it took through it? Like if you wanted to only take like 5 steps through it, you could specify that. But now it went through that and it saw that the shellcode is using load library A and loading the WS232, which is what we saw in the debugger. Then it is creating that socket connection, and then yeah, it's using create process CMD with whatever parameters attached to it. Yeah, so that's pretty interesting. Hello from Bulgaria. Hello. That's quite some ways. That's pretty cool. That's actually really cool. The warfault.exe thing already died, so I'll just gonna I'll just take a screenshot of this. Whoops. Yeah, that's pretty cool. So yeah, that's the commit that basically got saved to us. We'll put this here, and then we'll do this. Oh yeah, and then RWX. Hello from PR Webo. Hello. Okay, so let's add these screenshots to the dynamic analysis. Right, so if we actually want to make a report on this, we should probably make some better notes. Building your English technical vocabulary, nice. But I mean, yeah, we got the shell code. We could try writing Yara rules for it if we wanted to. I'm gonna just call this stage 0. Wow. Oh, excuse me. All right, does anyone have any questions on like what the heck we just did up until now? Are you using green shot for screenshot? No, I'm using flame shot. It's on my host machine. You can see it right here. Open launcher. Yeah. I have i5 11 Gen Intel processor here. Let me open up the chat over here. There you go. DDR4 RAM, 512, blah, blah, blah. But when I use Flare VM around Linux, it lags. I'm using VMware Workstation tips to get it to run faster. I'm not sure. Maybe if you have enough. How much RAM do you have? 16 gigabytes of RAM? Okay. Give like Remnux only needs like 2 gigabytes, 4 at the most. Windows, because you know Flare is like a Windows box. I would give Flare at least 4 to 8, you know, and then your processor will just be the processor. I think VMware and VMware is a little bit better. I know VirtualBox is a little bit hefty. I use QEMU, like QEMU QVM, for my virtual machines, so they tend to be really fast and pretty smooth. So I don't really have to worry too much about those types of things. 2 gigs per each? No. I would give Windows, yeah, like 4 to 8 at least. Yeah. Let me see what my stats are. So yeah, memory. Yeah, Windows has 4. I have a similar setup. Can I run VMs just fine? Yeah, you should be able to. QEMU? I already have a video on it on my channel. I think I showed this at the beginning of the stream, but yeah, that's Malware Lab. It shows you exactly how I set up my virtual machine, both of them, all the other stuff. So if you guys want to, you guys can. But that's good. We actually got the shellcode, which is all we really needed. I guess we can throw it into something like, okay, I mean, yeah, we already looked at the stager. Let's see if we can look at the word fault executable really quickly. Because the word fault, like literally there's no, it looks like there's like no obfuscation here. Let's use cutter. Yeah, of course, man. My QEMU is like, I have it running on Linux. Like I run Linux Mint as a main operating system, yeah. And then I have virtual machines running on my Linux computer, which is why I'm using QEMU, because it's a little bit smoother and faster. I have VirtualBox too, but I don't really like to use VirtualBox that much. It's a little bit slower. Okay, so let's go ahead and select our file. We're going to go to desktop and then malware stage 0. Yeah, okay. All right, when main is startup, so let's find main. Oh yeah, it's a nim binary. Isn't it nim main? Nim main inner setup shop? What the hell is setup shop? So setup shop creates a bunch of variables. New string stream. Okay. So test the AX and then jump not equal. So what is this setup shop doing? Do file stream, some other stuff. Okay. So if it is equal, it goes over here to save point. Copy string, echo bin. Man, this is interesting code base. Is there anything I have to like worry about? Like, can I just start running through it? The sub shop function is weird. What desktop environment? Or yeah, I'm using i3. Yeah, i3 window manager. i7 host. What are you talking about? Like the processor? Probably. Yeah, i7. Something crazy. I might so sim right line. So right line. Pop current exception. Sim raise exception. Raw new strain. Okay. Oops. I did not mean to close that window. I thought I opened that window again. Streams, imports. I didn't really look at the imports past like how it wasn't. This is load library A. Oh yeah, this is the, okay, hold up. This is not even the file I wanted to look at for real. Discard, yeah. I want to look at word fault because word fault. Oh, look at that. Is debugger present? Is processor feature present? Okay, let's check this out because we already kind of understand how the malware is working. It has the payload shellcode and then it ejects it. How am I? I'm doing good, man. I'm doing good. Having some fun. We're poking at some malware. You good though? Am I good? I'm decent. I think there's, you know, people who do this professionally and they're probably better at it than I am, but I'm just having fun. Word fault.exe. Okay, let's open this. Okay. So this one has debugger detection. You see that? That's so weird, dude. So close handle, close remote thread, open process. That's so weird, dude. All right. View. Windows functions. Okay, so let's go to main. Okay, so this is a normal freaking program because there's not like 18 main functions. So the main function, here's the disassembly. Open process. Virtual lock. Write process memory, create remote thread, close handle. Okay, that makes sense. Where is it? Here, graph. It has to be doing some sort of check though. Like there's no way this just runs first. Call A to I. Call function. Is processor feature. Is processor feature present? I don't think I've heard of this. Am I going to patch it? Yeah, I'll patch it. Is process feature present. Determines whether the specified processor feature is supported by the current computer. So this is just another like VM detection thing. What number are they using? Hex 17? Was that 23? Yeah, 23. Where's 23? Fast fail available? I don't think that's right. What's Hex 17? 7 plus... Yeah, that's 23. Fast fail is available. What the hell is fast fail? Fast fail is available. It's just a way of detecting. This just took me to the same freaking page. Have each code base of. Oh, it's a termination type thing. Okay, but basically this is just VM detection. So this does have VM detection. That's pretty interesting. So yeah, we're basically just going to patch that. But there's also is debugger present? So let's see if we can go to the jump equal. Isn't there a way you can just swap the jump? I'm pretty sure there is. Edit, reverse jump. That's what it is. Oh, reopen in write mode. Did that work? Did that go from jump not equals to... I honestly wasn't even paying attention. I'm glad the video stuff helped you out, man. Have you been developing your own malware since? Okay, let's just... discard. We're just going to reopen this because this is being weird. Yes. Load in write mode. Okay. We'll close the debugger. We don't need it. Yes. Okay, main. Let's go to main. So it's calling this function right here. Is there any other function call it does? No. Yeah, because after this, it starts doing open process and all this other stuff. So create remote thread, close handle. So compare, jump not equal, find is processor feature present. What is this function called? terminate process. What? You need run PE to inject the stub to pause the exe, inject the stub to memory, return. I have my own cryptor build. I'm just having fun here, man. I'm just trying to figure out what this is actually doing. Process injection is already obsolete and will be detected. Bro, I'm not dude, I'm not developing malware. I mean, read the title. I'm analyzing. I'm looking at someone else's. I'm not trying to do process injection right now. Though I appreciate your insight. So this really like skips to here. I don't know if I'm actually supposed to skip this jump or not. No, you're all good. You're all good. Is this like a? Do you guys know if this is a VM detection thing? VM detection? Question mark. Yeah, is this used for VM detection? All right. Yeah, Reddit's just being weird. Yo, Cosmo Assembly. You know it. How do applications? This might not be for VM detection. I'm going to ignore it for now. But we need to find that debugger present function. Where is that? Alright, whatever. We'll just step through the freaking code. So let's check out this function call. Get current process, terminate process. So this is like the kill function. Interesting. What's up, Iwa? Yeah, Iwa. I think I said that right. I'm just trying to figure out where the hell they're calling that function. This is A2I. There's really no other function calls other than like the 132 ones, obviously. You know what? Let's just run it. x32dbg. Let's go to this PC. See users. Public. Warfault.exe. And change command line. Yeah, because it wants to have the Warfault process. Here, if it's a process injector, it shouldn't matter, right? So can I just open up like notepad.++? Let's do a normal one. Let's just do notepad. Good old normal notepad. And can we inject into this? Because I don't think it matters, right? All right, notepad is 7444. So let's change command line. Why won't it let me change the command line? Hello? Change command line. What on earth is going on? This PC. Users. Public. You know what? Maybe if I paste this into desktop. There you go. And then change command line. There you go. Okay. So what was it? 7444. Okay. So with that, let's do some breakpoints on the debugger stuff. So breakpoint debugger present question mark. I did not. First of all, I didn't spell that right. What's the name of the function again? Is debugger present. Breakpoint is debugger present. Invalid address. Is it a capital I? What's going on? It is a capital I. Wow. Excuse me. There you go. All right. Any other ones that we want to look at? So create process, write process memory probably. I'm sure this function has an address too. Oops. No, forget. We'll do a breakpoint, write process memory. All right. Let's do that. I'm curious because write process memory should have the address of the memory space. LP base address. So the second parameter, it looks like. So let's go ahead and run this. We'll keep an eye on Notepad. So we hit the entry point, we hit write process memory, and so the second parameter is supposed to be the address of the memory that gets written to, question mark? Right? LP void, it's the pointer to the base address. Or am I tripping? It's the the buffer that contains the data to be written. Oh, so it's the third parameter. Okay. Let's look at the third parameter. Open in dump. So for FF7D. All right, well, let's execute to return. Just a quick question. I've done a degree in software dev and currently doing a degree in cyber. What are the best to do in the future? Our best jobs? Yeah, I will go with Dr. Wolf said. I'm sure their list is pretty good, but it really is kind of dependent on what you want to do. I'm more interested in development stuff, so that's kind of the path I've gone on. A lot of like malware development, payload development, offensive development type stuff. And then in my hobbyist time is this malware analysis stuff, but but yeah, I'm sure his list will offer better guidance than I could give you. So if we step over the return, look at, so the process memory had to be written to by now. I didn't really look at the function calls here. What was that last? Was there like a virtual protect or anything like that? Virtual lock. So is it just writing straight RWX? Yeah, I don't really know. But I think like it doesn't matter too much because I mean we really got the shellcode. You know what I mean? Oh no, is there anything else I should be looking at? Because we don't really have an end goal anymore because we found the shellcode. Sorry guys, I'm checking something on my phone. I think it would be cool to patch this binary. And then, but like at the same time, the other malware is already like, oh, excuse me. Yeah, the other malware is already writing to it. You know what I mean? Or like, I don't know if I'm explaining this very well, so I'm sorry. Four kilobytes, read write. Interesting. Another question. I'm currently running Linux and love it, but when I want to develop for Windows, I just run a Windows VM without a dedicated GPU. Should I buy another GPU just for the VMs? Or is there a better option? I mean, what hardcore Windows development do you need a GPU for? I mean, I have, here, let me go on like, Control, 0. Is it like slow? What virtual machine software are you using? Because my virtual machines have been running fine. Plus, I'm sure with QEMU you could add like hardware and stuff. Add hardware, you know what I mean? Graphics. I mean, but I'm using QEMU. What? Yeah, you're using QEMU too. Okay. Yeah, I don't know. I haven't had any issues. Like I'm running like 2 virtual machines right now too. And then like I have a separate Windows virtual machine for malware development. We just want to do a category switch. Honestly, I think I'm good with the malware analysis, guys. I think we kind of covered everything. Like we saw everything we needed to. Only thing we could go further with is like patching the binary and stuff like that. In Windows, I run Visual Studio and other heavy programs. Here, let's all right, sidetrack. I'm going to, yeah, we don't really need this stuff anymore. Next live stream, honestly, we'll just keep streaming, bro. I'm not even doing anything right now, so we'll just chill for a little bit. Yeah, we'll just chill for a little bit. I wanted to try to stream once a week though. I think that would be ideal. Though I'm going out of town for a little bit. Yeah, don't say this. All right. Yeah, honestly, just power the machine off. Yeah. Let's boot up my malware development virtual machine. So Alt-0, Windows Q, Windows 10. All right, let's boot this up. Next live stream, yeah. Oh, you gotta go sleep, no worries. Good night, love from India. Oh, that's awesome, dude. Okay. It's actually not this slow usually, it's just because I'm streaming. There's like a lot of, I don't know, overhaul. Close this. Yeah, all right, I'll close this other stuff. I don't really need it. Cool. But yeah, like VS, I haven't had many issues with on here. I'm sure now that I'm streaming, like it's going to be a little bit more hefty. Yeah, you can already see my CPU's going up a little bit just because of the stream. But yeah, no, I haven't had many issues with stuff like this. Maybe you can look into something with more support, because I have, like, you can get VirtualBox on Linux as well, and there might be better support for, like, I don't know, that stuff. What's the Windows development for? Is it like malware, or is it like game development or anything like that? I don't even know if you're still here. I'll give you a few more seconds to respond. If not, it's fine. There's also something I wanted to check out. Wasn't it like Glaze? Oh, just trying out C#. Got you. I mean, yeah. I mean, yeah. I mean, you can look into it. I didn't even know this was like, I've never really considered getting like a secondary GPU for virtual machine stuff. That could be really cool. Have people done that, like through QEMU? Second GPU pass through QEMU. QVM architecture. So I'm looking at this diagram. I've actually never like looked into how QEMU works and all that stuff. It's actually kind of cool. Maybe we just want to get this set up. I want to launch a Windows VMs for gaming. Interesting. While still being on your Linux host for development and work. At this point, you might be wondering why not just game on Linux. Blah blah blah. Hardware requirements. To achieve a high performance virtual machine, 2 graphics cards, hardware that supports IOMU. Interesting. This is cool, dude. I had never installed the necessary packages. I already have these. So this is Debian focused. It's kind of cool. ACS override patch. It's really weird because I can run multiple VMs, but when I run Tiny 11, yeah, Tiny window, yeah, it slows it all down. Maybe it's just a Windows 11 thing. Are your other ones? Because my virtual machines are still Windows 10. I never upgraded them to 11. Because Windows 11 is a little bit heftier, right? Doesn't it need like Windows 11 specs? Oh yeah, system requirements. That's what I'm looking for. Windows 11 system requirements. Okay. So 4 gigs of RAM. Storage 64 gigabytes. Interesting. It's kind of crazy how much like specs have gone up for like system requirements. We keep looking at this. This is actually really cool. I kind of want to take like a laptop and just start trying some of this stuff. I wouldn't use this on my main laptop until I know it works on the other laptop. You know what I mean? Hooks 110. Wow. This is a cool project. I honestly kind of want to I want to try something like this. Creating the VM. Okay, so then they create the VM after doing all this mumbo jumbo. So what do they do on the Vert Manager? Do they have to add? So CPUs enable available CPU security flaw mitigations to prevent against Spectre and Meltdown vulnerabilities. Whoa, I even know I should have done that. Is my machine doing that? CPUs. Copy host CPU configuration. That's what it said, right? Oh, I think they're adding hardware. Yeah, add hardware. No. What are they doing? Oh, this is the, oh, this is when you create the actual machine. Yeah, this is the more options. Huh. I've chosen to remove several of the menu options that won't be useful to my setup. Feel free to keep them if you like. Wow. So they're adding the virtual input output devices. Suckless? I don't think so. Software that sucks less, like DWM and all that stuff. No, I use i3. All right, so network stuff. Wow, this is super cool. I'm bookmarking this. This is, wow. Yeah, what I was about to say is I saw something called Glaze Window Manager, and it's a Windows. Like, look at this. What? Wait, okay. Like, this is Windows. I was thinking of setting this up on my Windows VM. I saw some guy on r/Unix porn with this. I don't know, just looks really cool. And you can use winget. And then configurations. Let me look at key bindings. When you're making the video about this, I'll be the first to watch it. That's a bet. So key bindings, focus workspace 1, Alt 1, okay. Alt shift to move to focus. Command focus left. These are the default ones. Oh wow, so this is basically what I already have set up for the most part. I would probably maximize to F. and then use the default. Yeah, Terminator ones. Okay, this is cool. I really want to set this up now. I don't know if I want to set it up right now, but I want to set this up. All right, next stream we'll probably set this up. That's super wicked. Workspaces, you can give them names. I'm just curious on how, like, out the box it comes out. Yeah, easy one-click installation. Yeah, no, that looks freaking sweet, dude. And I notice he has a GIF playing in the background. Is that wallpaper part of the is it part of the, like, window manager? Oh, they're porting it over to Rust. Look at that. I'm sure you would love that image, John. Wow, okay. That's really cool. That's literally going to be the next project, next stream, whatever. But yeah, I'll probably cut the stream here. I think we already did enough of the malware analysis stuff, and then I feel like if we get too sidetracked, people will get lost and confused. Window Manager and Windows before GTA 6. I know. It's a shame, man. It's a shame. But it looks really nice, dude. Yeah, 4K stars. Yeah, that's a pretty good. Inspired by i3 and Polybar too. That's literally what I'm using. i3 and Polybar. Yeah, I'll give this a shot. This will be a future stream then. Yeah. All right, I'll let you guys enjoy the rest of your Saturday. Good seeing you guys again. Hope you guys, I don't know, have a good rest of your day, and I'll see you guys soon. Happy hacking.